First, we're going to look at solving equations that have an x with something added to them or an x with something multiplied by them. To solve these equations, we go backwards, or we undo what has been done to x in order to solve the equation. In equations, as long as we do the same thing to both sides, our equality will still hold. Think of a balance. When you have an equation, you have a balance, one side and the other. As long as you do the same thing to both sides of the equation, you will still have an equality that holds, an equal equation. So start on the side that has the x. Now when I say x, I mean the variable. Some of these problems have different variables in them. So start on the side with the x. Undo what's been done to the x until we get x by itself. These will all be one-steppers, one-step problems. So start on the side with the x, over here. What has been done to the x? Well, add 3. I want to do the inverse operation of that. So I want to subtract 3 from both sides. What will happen? Well, you bring down your c. Positive 3 minus 3 adds up to be nothing, 0, so that's gone. Equals 5 minus 3 is 2. C equals 2. There's our answer. Remember, I am not looking for just the answer. I understand that you could look at this problem and see that 2 was the answer and be able to write down C equals 2 without showing the algebra steps. That's not what I'm checking. When I check this homework, I will be looking at this even more so than I look for the answer. You will not receive credit if you just put the answer. 10 plus x equals negative 8. Again, go to the side with the x. That's this side. And what has been done to the x? Well, we have a 10 here, a positive 10 that's been added on. So we're going to subtract 10 from both sides. Undo what's been done to the x. 10 minus 10 is 0, nothing. Bring down your x. Bring down your equals. Think money, negative 8 and negative 10 makes negative 18. You'll do a lot of work with negatives when you're solving these problems. So you might want to go back and review your negative rules. Negative 8 equals n plus 3. Start on the side with the x, or the side with the variable. Undo what has been done to the variable. So right now we have a plus 3. I want to do the inverse of that, the opposite of that. I want a minus 3 from both sides. Negative 8 and negative 3, think money, you lose 8, you lose 3, you're 11 in the hole. Negative 11 equals, bring down your n, plus 3 and minus 3 equals 0, that's gone. So your answer is negative 11 equals n, or n equals negative 11. It's okay to leave it with that n on the other side. Negative 2 plus y equals negative 6. Got a y here. Start on the side with the variable. Undo what's been done to the variable. So I've got a minus 2. Okay, since this minus sign is here, to undo that, I want to do add 2. That's how I'll make that add up to be 0 to get out of there. Negative 2 plus 2, that's gone. So I have y. Bring down my equals. Then negative 6 plus 2, think money. You're 6 in the hole. You get 2 back. You're still in the hole, but only at negative 4. Y equals negative 4. Again, I'm checking for this work, not even so much the answer. Okay, these problems all have numbers that are multiplied by the variable. How do we undo that? Well, 3 times c equals 12. Again, start on the side with the variable, undo what's been done to the c. So right now, I have c times 3. So to undo that, to undo multiply, I want to do the opposite of multiply, which is divide. C equals 4. Now I just crossed out that, but let's go back and talk about that a little bit. 3 divided by 3, what actually happens there? When you have 3 divided by 3, you get 1. 1c, which is the same as c. Okay. Again, start on the side with the variable. So over here, undo what's been done to the y. So 4 has been multiplied by y, so to undo that, I divide both sides by 4. 4 divided by 4 cancels, or that's 1 or 1y equals negative 8. Start on the side with the variable. Undo what's been done to the variable. So right now, it's 4 times a. So to undo timesing by 4, I want to divide by 4. A equals 0 divided by 4 is 0. Couple things this problem is trying to catch you on. First, you have to start on the side with the variable. So we're actually going to start over here on the right side of the equation this time. I have negative 18 times x. So I want to undo timesing by negative 18. So I'll divide by negative 18 on both sides. Be careful. A common wrong answer here is negative 3. But notice that this is a proper fraction, 6 divided by 18. That's actually, if you reduce that equation, if you divide both top and bottom by 6, you get negative 1/3. 6/18 is negative 1/3. Negative x equals 2. Some people want to just leave it like that, negative x equals 2, but you can't. You can't have that negative sign in front of there. So how do we get rid of it? There's a couple ways to think about this problem. Here's how I think about it. I think about it like a negative 1x. Remember, when there's no coefficient, it's like there's a coefficient of 1. So negative 1 times x, how do I undo timesing by negative 1? Well, I divide by negative 1. So I get x, those two negative ones cancel, equals 2 divided by negative 1 is negative 2. So here, start on the side with a variable, undo a negative, or undo timesing by negative 1. So divide both sides by negative 1. Negative divided by a negative is a positive, so this side becomes positive x equals positive 5. Let's talk about these fractions a little bit. 3/4 times y equals 9. Now, to undo timesing, I would divide both sides by 3/4. We commonly use a shortcut, though. When you divide by a fraction, it's the same thing as multiplying it by its reciprocal. So to get rid of timesing by 3/4, if I multiply both sides by 4/3, let's look at what happens. We've talked about this before. When you multiply a number by its reciprocal, it turns into a 1, right? 12/12 is 1. So these cancel, or turn into 1. 1y equals, multiply your fractions, tops then bottoms. So 9 times 4 is 36. 1 times 3 is 3. 36/3, 36 divided by 3, which is 12. This problem is very similar. I just wanted you to see how some of them look a little different. 3/4 y is the same thing as 3y over 4. Even though they look a little different, those two are the same problem. So I would do this problem the exact same way as this previous one. 9 equals negative 3z over 8. Again, that's the same as 9 equals negative 3/8 z. So to undo timesing by a fraction, I divide by that fraction, or another way of doing that is just to multiply by its reciprocal on both sides. Now, I'm tempted just to cross this off because that's what's going to happen here. But check out what happens mathematically. If you multiply the negative by the negative, it'll be a positive. It'll be positive 24 over 24, which is 1z. So these two kind of just cancel out to make a 1z. It's getting z by itself is what it's doing. And then I multiply the other side, so I will get tops negative 72 over bottoms is 3. 72 divided by 3 is 24, so this is negative 24. 8 equals negative 2/3 x. Again, multiply by the reciprocal. Multiplying by that reciprocal undoes this or turns that to a 1x equals, now multiply out our other side, negative 24 over 2, which simplifies to negative 12. Let's practice. First, what will the directions look like for these problems? These problems have equal signs in them. They're equations, so these are equations. And the directions will say solve, get an answer for, x equals something. At this point, if you know how to do these, feel free to skim the video to the end to just check your answers. Go to the side with the x, undo what's been done to the x, so I will divide both sides by 3, giving me x equals 5. Go to the side of the x, undo what's been done to the x, divide both sides by negative 20. The undo of timesing by negative 20 is to divide by negative 20. So that makes x equals 1/2. Be careful on your reducing there. Go to the side with the x, undo what's been done to the x. I have a positive 9 right here, so I have to subtract 9 from both sides. X equals negative 11. Go to the side with the x, undo what's been done to the x. I have a positive 3, so I want to subtract 3 from both sides. Negative 11 equals x. Five equals negative x. I have to get rid of that negative before I'm done. So I like to divide both sides by negative 1. That cancels out the negative and gives you x equals negative 5. 10 equals x over 5. Well, an x is the same thing as 1x. So this is the same thing as 10 equals 1/5 x. To undo timesing by a fraction, I can multiply by its reciprocal. The reciprocal of 1/5 is 5 over 1, or 5. So I'm going to multiply both sides by 5. That turns this into a 1, or 1x equals 50. Start on the side with the x. To undo timesing by a fraction, multiply both sides by its reciprocal. That cancels this or turns it into 1. 1x equals, multiply your tops, negative 30, multiply your bottoms, 3. Negative 30 divided by 3 is negative 10. Negative 1/2 x equals negative 12. In order to undo timesing by a fraction, multiply by its reciprocal. Notice I still have to keep it negative. Negative 2 times negative 1/2 will cancel out or turn into 1. 1x equals negative 12 times negative 2 is positive 24. 7 equals negative x. Divide both sides by negative 1. That'll turn that negative sign into a positive, giving us x equals negative 7. I want to get x by itself. Start on the side that has the x. Undo a negative 2. To get rid of that, you have to actually add 2 to both sides. Because then negative 2 plus 2 will add up to be 0. So you'll have x equals 9. 10x equals 5. Divide both sides by 10. Remember, start on the side with the x. That's how I know to divide both sides by 10 and not to divide both sides by 5. X equals 1/2. X plus 9 equals 4. I want to subtract 9 from both sides. X equals, think money, 4 and negative 9. You had $4, you lost 9. Now you're in the whole 5. X equals negative 5. Negative 2x equals 22. Go to the side with the x and undo multiplying by negative 2. The undo for multiplying negative 2 is to divide by negative 2. X equals negative 11. I want to say this again. A lot of people think if they can do it without the algebra steps, to just do it that way. I'm not teaching you that, though. I'm not teaching you how to get an answer. I'm trying to teach you the algebra steps. That's what we're learning today.